those three problems from last biweekly contest. Let's look at the third problem first. Zero array transformation part 3. We had part 1 and part 2 in previous contest. I suggest we look at that first. We're given integer array nums of length n and few queries, and we are told that these queries are nothing but a range, and we can use this range, and in this range uh, we can just reduce at most one or not reduce anything, uh, and we are to do this so that we are able to make the array or the numbers array a zero array, which means all the elements are equal to zero. We are asked to find the maximum number of elements of the queries that can be unused, so that the minimum number of queries are used and we are able to make a zero array. Right? We want to find the remaining arrays count. So this is the problem. So for this example, 202, 02 if we choose, then we are able to 012, right? We are able to reduce this by 101. If we choose 02 again, then we are able to make it 000. So we don't need 1 comma 1 right? Because 1 comma 1 is already 0. So the second example here, 1 comma 3. If we choose that, then we are able to make these 0, 0 comma 2. I think we are done. So we can leave the last two, or we can use others as well in any combination, and we still be able to use only two, and remaining two will be our answer. So this is the problem. Right away, this uh, concept is going to be used here. So if you're given an array 1, 2, 3, 4, 5, 6, and we can use the queries, which might be something like uh, 0 comma 2, uh, let me take it value 0 comma 2, right? So if I want to utilize or consume these queries and perform action on this numbers array, then what I can do is optimally I can select the lower index, that is this one, and do a +1 here or a -1 here, since we are decrementing in this particular example, and 0, 1, 2, 3, 4, 5, let me take 1, 7. Alright, so for this particular index, if I write down the index, I will choose one greater than the upper bound of the query and do a +1 here, and suppose this was a prefix and I did this action in the prefix. Now if I do a prefix, then this will be the result, and I'm able to achieve a decrement on the ranges that I expected or I wanted to perform action on, and hence the first query is consumed. Similarly, I can do the same thing for the second query. So this is called line sweep algorithm, and which is going to be used in this problem. So if I look at the problem, I don't really get anything right. It's not very intuitive, except the fact that we can use this line sweep algorithm. But if we use this algorithm, even then we are not able to find the unused queries, right? So it's a different problem. But still the same concept is going to be used. Since it's unintuitive, we should optimally use queries, and in order to do that, we should look at this problem in something like a range interval problem where we have common intervals, right? And we want to only utilize the maximum, uh, uh, the biggest interval that we can in the common intervals, right? So if I take the example of something like if I have this query and I have this query and I am asked to perform on some numbers array, right? In that case, I'm going to use this particular query first, and then if there are remaining indexes which are still not zero, then I'm going to use this, right? So this suggests us that we can sort the queries, right? If we sort the queries, then we are able to at least uh, get the correct order of the queries uh, in which it should be consumed, right? So if we sort the query, suppose this is sorted, in that case this will be 0 to 1 3, or actually, yeah, 1 3 1 3 1 2, right? This will be the sorted queries. Now since we are good in terms of the order of the queries, now we can just iterate on numbers array, and for each iteration we will have an index, right? This is index 0. So at this index 0, we are going to load the queries into a priority queue. Why a priority queue? Because the fact that I just told you, we can utilize the priority queue so that we are able to utilize the biggest array first, and then the smaller, the biggest query first, and then the smaller queries in that particular range. So first we see first we see the index in the number array, we see 0. Now we load the queries which are already sorted into priority queue with the index such that the upper bound gets sorted in descending order. That's the first thing. The second thing is we do that for all the queries which are covering the range 0, this one. Okay? So in this case, this one is covered by only this, right? There is nothing else, no other queries covering 0. So only this query is covering 0. So I load it up in the priority queue, perform the action on the a prefix sum that I create, and do the same thing for the next uh, index if the prefix sum and the current index sum is not greater than 0, right? So let's solve it, or probably let's write down the points. The first point is sort the queries. Second point is process or iterate the numbers array, iterate nums. Third thing is for each nums index, let's call it I, load the queries, load all the queries which cover index I into priority queue such that the upper bound is in descending order. The fourth point is update the action or the update the query on prefix array until either the queries are exhausted, the queries or the priority queue is exhausted, or the nums index is fulfilled. Nums I plus probably the prefix, let's call it, of uh, I, prefix of I is uh, equal to 0, right? Till then continue, and after exhausting all the queries, even then it's not 0, then return -1. If PQ exhausted and not still this is not true, then return -1. Otherwise, just continue process, and at the end return whatever the priority queue is containing, right? It contains few unused queries, right? And that will be our answer. So first thing first, let's sort the queries, or probably let's get the queries dot size. We'll be needing it. Queries dot begin, queries dot end. Got it. At this point, uh, let's have an answer in which, or no, let's have a priority queue. It will be a min heap or a max heap. Let's see, descending order, and two indexes will be there, right? So it will be a pair of int comma int will be a max heap. So vector of pair of int comma it will be a max heap. So that. So we put right here. Now let's have I, which will be iterator or pointer of nums. Probably let's call it nums index. Let's have G. Let's call it queries index. While I is less than nums dot size. Keep continuing. Let's do I plus plus here. So at this point, I should uh, load all the queries. By the way, we also need a prefix one, a prefix array. It will be of size numbers array, right? So prefix size will be nums dot size. So let's have n also. let's have n. This will be of size n. So at this point we need to check if I is already greater than 0, since we are also going to build up the prefix sum. So let's build it up as we go. Right here, if I is greater than 0, then I prefix of I will be prefix of I plus or minus 1, right? So this is our current number of decrements that is possible on this particular index at this point. Right? So now load the queries within covering the index I. So let's load the queries which are covering the index. So while the query index within bounds, which is less than n, and uh, the lower bound of query, that is this one, sorry, should be j, if it is less than equal to I, which means it's covering the index. But should I check for the upper index? I should not. Why? Because if I check for the upper index, then essentially I am, you know, if these are the sorted queries, then I am here. I'm loading for this particular index. I'm loading it inside priority queue. But since this particular index is out of bound, I will not load this query. And ultimately, since I'm going to return the priority queue size, I should load all the queries, right? So I should load all the queries, which means I should not check for the upper bound right here. And now since we have the queries, I'll put it inside the priority queue. In which order? My sorting index inside the priority queue is the upper bound, right? Upper bound should be descending order. So I should load this accordingly. It should be j, and the second index will be, actually the second index is not even needed, to be honest. Or actually it's needed, by the way. Sorry, it's needed because we are going to update it on the prefix array, right? Alright, so we load it inside the priority queue. It's time to consume it. Consume the query as long as it is not exhausted. And now right here, since we are not checking for the upper bound here, we should check for the upper bound here. And within bounds and nums of I plus prefix of I should be greater than 0. As long as this is greater than 0, it is not exhausted and it is within bounds. Keep continuing. So while priority queue is not empty, it is within bounds. So I, or the upper bound, which is inside the priority queue, that is priority queue dot top first, or I think it's like this. First is the upper bound and should be greater than equal to I, and finally nums of I plus prefix of I is greater than 0. That means I should consume this query and I should update it in the prefix array. So I will get the indexes or the range, that is L comma U, or probably U comma L, is equal to priority queue dot top, priority queue dot pop, perform action on prefix array, which is prefix. So right here, since we are at a particular index I, we should not update the prefix of previous or the lower bound of the query, right? For this particular index, we should not update it for the lower bound of query because we are not going to find the prefix sum again. And we don't care about for the indexes before I, right? We have already processed it. So it's safe to update the prefix of I by decrementing it by 1 and the prefix of the upper bound incrementing it by 1, and we are good. So at this point we have exhausted the priority queue, but still nums of I plus prefix of I is greater than 0. In that case return -1 and increment I plus plus, that's correct. And finally return the priority queue size. Let's see if this works. Uh-oh, I think I am not popping it. Priority queue dot empty and priority queue dot top first should be greater than equal to I. Yeah, I am not incrementing J. We should increment J here. Otherwise, we'll keep loading it inside the priority queue. Okay, prefix of U plus 1. I think we should have one size greater than nums of size, because for the last index we want to update the index which is one out of bound, right? So that's why it should be n plus 1. Let's see now. Okay, let's submit it. The time complexity, since we are using priority queue, it will be n log n, and the space complexity will be O of n, right? So the second problem, shift distance between two strings. We are given a string s at string t and a next cost which is of size 26 or 20, yeah, 26 size, and similarly previous cost which is also size 26. Yeah, and we are asked to find or we are asked to convert s into t either by incrementing a forward or decrementing a backward, right? Backward, by backward we mean a is going to z, then y, then x, and so on and so forth. And if we make it go backward, then suppose a is going to z, then I am going to use the previous cost of what index? Of the index that is equivalent to a, that is 0. So 1 will be my count, 1 will be my cost. And then from z to y, that will be of course 0, because of index z will be equivalent to 25 index, and that will be 0. And that will go on and on and on until we reach b. So a to b will be of cost 1. That will be the minimum cost, and that's what we want to find, the minimum total cost of all the operations to convert s to t, right? So we can just simulate this. Since it's just 26 letters, we can just iterate s, do both ways cost and take the minimum and do that for every index, and eventually that will be our answer. So let's have our answer long iterate the index. Uh, let's have a cost, or uh, let's have a index initially, or index 1 initially, s of I minus e. This is our initial index, and our cost will be initially cost 1 will be 0, right? So cost 1 is basically indicating previous cost. So I can always do a previous operation or a next operation and get to the point which is equivalent to T of I. So I'll do the same for the next as well. First do it for the previous cost. So while T of I is not equal to uh, 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 yeah, probably index 1 is not a very appropriate name, but who cares? Let's have it anyways. Index 1. If it is not equal to index 1, keep decrementing index 1 by 1, and also keep incrementing the cost by previous cost of index 1, right? That will give us the cost. So cost should be long, right? And by the way, since we are decrementing index 1, it can go negative. So if it goes negative, if it is less than 0, then make it equal to 25, right? And the same thing goes here, just that this time it will be index 2 cost 2, index 2 cost 2. This will be next cost, index 2. This will be incremented by 1, and I should also, if it is greater than 25, then I'll make it 0, and finally I'll increment my answer by whatever the cost, whichever cost is minimum, cost 1 comma cost 2, and let's return that answer. Hopefully I'm not missing anything. Let's see if it works. Okay, time limit exceed. Okay, this should be index 2 instead, and this should be index 2, index 2. Let's see now. Okay, the times complexity will be O of 1 or O of n, and space complexity will be O of 1, I believe. Let's see the first problem, stone removal game. We are given a setup. Alice and Bob are playing a game, and they take turns, and they are removing stones from a pile, which is basically performing an action on an integer n and removing exactly 10, points or 10 units from it. And the subsequent one will be a removal of 9, and then 8, and then 7, 6, 5, until there is a point where the player cannot make a move, loses the game, right? Okay, so let's simulate it. Let's have a boolean. Is Alice a stone? Then initially it will be true. Let's have a s, which is initially 10 because 10 units needs to be removed. While s is greater than 0, we can keep removing it. So we will remove, sorry, we'll remove n minus equal to s. Sorry, let's decrement it. So the next time we remove 9 units, next time we remove 8 units, and so on and so forth. At this point, if uh, after removal, that is from n, s has been removed. If after removal n is less than 0, then it's time to tell who has won the game. We will return whoever's index, whoever's turn it was, that is, if it was Alice's turn or not. And then every time, since turns will change, so I will do a toggle on this particular field, and I'm going to return true here. I think it will never reach this point because the constraints are given accordingly. Okay, I think since Alice won, then it should return true. So this should be the returning answer. Yeah, let's submit it. The time complexity will be O of 1, kind of, since we have only 10 removals and then 8 removals and then so on and so forth. And the space complexity will be O of 1. Yeah, so that's the 3 problems. The fourth problem probably I'll bring it up tomorrow. Thanks.